Hello everybody, welcome to another Zabbix video. This time I'm talking about data collection, update frequency for Zabbix items, and there is no such thing as randomness for passive Zabbix items. Everything is hard-coded and it's based on what's the item ID and what is the scheduled update frequency for the item. Let's the use case or like why this can get important is there is actually not many of them, but one of them is Windows PowerShell, for example, because PowerShell one-liners or scripts sometimes take more than 1 second to complete, or even if we code like a Python code in the Linux, maybe the script needs to take time to complete. And if that script is used multiple times throughout the minute, there is a risk of overlapping. And so this video should answer, like, at least give some sort of workaround how we orchestrate the data collection to not overlap. And it will be highly related with the low-level discovery. So let's have a look. At the very beginning, I want to highlight how the algorithm works. And the algorithm is related at first with the passive items, and by passive items we mean like a Zabbix agent, simple check, SNMP agent, external check, database monitoring, SSH agent, calculated. So I name few passive items, and my point here is like there is no such thing as randomness. Zabbix will know exactly when to do the collection, and if you know the algorithm, you can also kind of, like when it will do, and there will be no such thing like when this must be executed, and let's cover that algorithm. And I will cover on the screen. Let's select calculated item here. Memory utilization. This item executes every 1 minute, and the item comes from the template, and when we apply the template to the host, then item will have unique ID, which is unique for this host object. Oh, yeah, what's important is like update frequency is 1 minute. Let's put that in the notes here. Update frequency, and actually inside the database level, this field is called delay. Update frequency 1 minute. Going back here, and item ID, to know the item ID, we can click latest data page, and now when we click the graph inside the URL, we see the item ID. This is the item ID and the formula, and item ID is this. And let's switch, like 1 minute means 60 seconds, and the formula is easy. It is, let's take the item ID, divide by the update frequency, which is 60, and not the normal divide, but divide which asks for the remaining, like when we do a full divide, like when we take this big number, divide by 60, what is the remaining? And we can see this inside the bash, like echo $, and it will support the algebra. If I put this in the terminal, then it will answer like what is the remaining, and the remaining is 49. Obviously it will never be more than 60, and actually it will never be more than 59, because if we divide like by 60, and when dividing by 60, and if there is no remaining, then there is no remaining. Okay, so this is the offset. So the answer is like offset equals offset is what was the offset? 49. So that's the answer. And what to do with this offset, we need to kind of look back in the year 1970, where Unix time was 0, and that's the answer. Like in the year 1970, the Unix time was 0, and if item is this, update frequency is this, it means the very first check will come with the 49 seconds past the midnight. Like this is the year, we have a midnight, we have a salute, and the first data collection will happen exactly like 49 seconds after the midnight, and then of course like we can quite easily figure out like when will be the next metric, and I think when we take 49 and add 60, because the update interval is 60, then the second metric will be here, and now you get the point. Like just add a little bit few years to go to the today, but yeah, the point is like it's everything is based on the offset, and this applies to all passive items, and it applies also for Zabbix agent to active items. It will use the same algorithm, and yeah, this is the how when it will collect. Okay, and obviously like if the item ID, there is a chance that if the item ID generates like some interesting number, we can by accident like always execute certain metrics at the same time. Let's say you are a hardcore Windows PowerShell user. We create like a discovery in the PowerShell, and the item prototype also will invoke another PowerShell script, and we want to collect every 1 minute. There is some risk like then that like it will generate an item ID with the which at the result like doing the conflict, and it's even like it's not possible to resolve that easily. The algorithm is kind of on the top of everything. It demands to use this logic, and so this video will kind of introduce a workaround how to orchestrate manually those items inside the through the low-level discovery. Let's have a look on one example. Inside the data collection templates, I have designed one template. My use case is VMI registry. Let's see on the item prototypes, like it's a native item key supported by Zabbix agent, and even this guy sometimes takes like some time to complete, and I would like to protect this query to avoid overlapping. Because it receives like a lot of text, and yeah, that's my taste. I mean, that's my preference here. Yeah, so here this is the item prototype, and it will accept different type of like tables to query what's inside, and those tables are listed inside here. I made like a manipulation. A calculated item, which is listing like a table, a CSV table. It's like almost like an Excel. Here is my values: Win32, baseboard, battery, BIOS, disk drive, like everything. And then inside the discovery section, I'm converting the CSV to the JSON. The low-level discovery loves the JSON. And my idea, like, I would love to a little bit have some orchestration and protect these queries to not execute at the same time. So what we can do is inside the discovery section, we can like inject extra dimension by help of Zabbix JavaScript. I mean, yeah, JavaScript. We can like add something extra inside that LLD JSON, and here what I'm practically doing is counting how many elements are inside the JSON and introducing these other low-level discovery macro sees that it will allow to access us to kind of install the offset manually, because we can have the scheduled check, and inside the scheduled check we can specify when exactly to execute, and here the install interval 1 second, it will be like first element can execute exactly 1 second past the current minute, the second element will execute second pass. It depends like how much time it needs to complete. Like you as a developer, as the owner of the script, like this script needs more than 1 second. If that's the case, then let's stick to this macro, which is like automatically adding the first will be when 0, the second will be 2, then 4, 6, 8, 10, and so on. This will be 3, 6, 9. So this will be probably good fit if second really needs to, if the script really needs 2 seconds to complete. If script needs 3 seconds to complete, then we will use this macro inside the item prototype, and we can now like really orchestrate when exactly to execute. Okay, yes, this is injecting like extra JSON element. Then there goes the mapping with my JSON, and inside the item prototype we have update interval 0, so it's like a manual overload. Like Zabbix will, it will not use the algorithm here. It will not use this algorithm because we introduce the we set the update interval 0 and we set custom interval, and here actually right now it does not support directly to put the LLD macro inside, but luckily at least it supports the $sign macro. So some ugliness must be inserted here. Like at the template level, I have 60 mapping elements here, 60 mappings, which like resolves to a very specific scheduled check. Okay, let's apply this module to the production. Click and click open over here, Windows OS, click update. So I have 67 items right now, and after 10 seconds or something, it will execute that calculated item, which holds a CSV file, and generate those other VMI get all items. Let's open, click. Now it's 87. If I put here get all, something like that, apply, and I have here, all those came, most of the, except the last one, those came from the template. And if we open it, then this is scheduled, like this will execute when there is 1 second past the current minute. The other one is 11 seconds past the current minute, 6 and so on. So it read the list and generated the offset to, like, at least these VMI queries, like there will be no queries which overlap. I mean, if there is less than 60, because we have right now my update interval actually is hard coded to 1 minute at the template level. Here the hard coded interval is minute divided by 1, which is every minute. And as far as the list is not bigger than 60, then those things never overlap. Okay, let's I will show how to orchestrate the worst case scenario to, like, better understand the risk, and the risk is very minimal. It's purely for entertainment purposes. Let's clone this template, clone, and worst add, and this template will be using item update frequency. I will like replace this to the for Zabbix to decide the update frequency based on that algorithm, not using this manual override remove. And for the test, I will set like 6 seconds should be the update frequency update, and on the top of that, like what like there is in real life, there is sometimes dependent items, and I will do that right now, like create some dummy dependent items. Click here, dependent item, like 1, yeah, like this, click, add, and I will create like 5 of them, and I hope you already understand where I'm going with that. So 6 seconds update interval, and 3 and 4, click, add, and 5, add. Yeah, so 6 seconds and 5 dependent items. So practically, if we think like when LLD discovery rule executes, it will generate like this. Let's say it will be item ID 1, 2, 3, 4, 5, 6, and then this will be item ID 7, 8, 9, 10, 11, 12, 13, and what it means, like this is a worst case scenario when we count all dependent items and the master item, and it's matching the number. Like we have like 6 items here in total. We here 6 items, and the update interval is 6. So what it means, like all the items will kind of like crash, and like they will always execute at the very same time. Let's like test this in practice. 6 update, and let's try to here pre-processing, remove this guy, update, and now I will link this worst case scenario on the host object. Click, unlink, worst, click, update. Okay, 67 right now, and it will generate. And we can actually validate this thing at the, like we can validate the offset at the database level. To do so, like I will connect to the database here, and we have like items table, select item ID, comma, delay, where, and maybe even like key, from items where host ID equals like this guy. Let's refresh the page, apply, and there are now more items, and we are looking for VMI get all, something like that. Like these are the ones, and yeah. I wanted the host ID. Host ID is over here in the URL. Copy, click, and maybe another condition, and key underscore like, and in the square brackets like something like get all. Okay, that's the item key, and enter. So these are my items. We see the delay is over here, and we can actually do the offset calculation at the level of the database over here. Just introduce the algebra immediately with the item ID, divide by delay, click, and as offset, comma, and enter. Item ID. yeah, I think I need manually hard code this guy. 6 is the update frequency. Enter, and we see the offset is always 4. So that is the damage. That's because the items are kind of increasing by 6. This is the what's the delay? We see 34 plus 6 is 40. Again, plus 6 is yeah. You get the point. Like it's the worst case scenario when like the orchestrated item IDs now is yeah, it's bad. Okay. Do I want to say something else? I guess not. Okay. That is everything for this video. It's like I think the takeaway I would like for you to have is just like be aware that there is not be aware, like just there is no such thing as randomness when we think about passive items. It is a strict algorithm, and the chance of having trouble is very low. Like it's lower than 1% from my point of view, but I would say it's not like 0.0001. The chance of like items to start a fight is like 0.2%, which is like which is yeah, there is some probability. That is everything. If you enjoyed this video, give it a thumbs up. If you survived till the end, I congratulate you. There is like a playlist in this channel, something called like Nerding Out with Zabbix Setup. So this video will definitely belong to that playlist where like you just care how things work deeply and like care more about like the outcome. Yeah, you care more about how it works than what's the outcome. So that's the playlist with this video will belong. And yeah, thanks for watching.